Mia, a sixth grader at Roosevelt Middle School, was thinking about joining middle school track team. She read that Olympic athletes have lower resting heart rates than most people. She wondered about her own heart rate and how it would compare to other students. Mia was interested in investigating the statistical question, what are the heart rates of the students in my sixth grade class? Do you see why that's a statistical question? Because its answers can vary. Heart rates are expressed as beats per minute, or BPM. Mia knew that her resting heart rate was 80 beats per minute. She asked her teacher if she could collect the heart rates of the other students in her class. The teacher's help, the other sixth graders in her class found their heart rates and reported them to Mia. Following are the heart rates in beats per minute for the 22 other students in Mia's class. So this is like in no specific order. She just went around, asked them what their resting heart rate was, and she recorded it on a sheet. So it starts at 89, but then it drops down to 87, 85, so it's random. To learn about the heart rates, a good place to start is to make a graph of the data. There's several different graphs that could be used, including the three types of graphs that you will learn in this module: dot plots, histograms, and box plots. But I don't know if we're going to get to box plots or stem and leaf or stem and whisker. But definitely dot plots, histograms are in the next 4 or 5 lessons. All right, so this is dot plots. Mia noticed, yeah, it's not bad at all. But what a graph does, or its intent, is to give you like a visual representation of the highs and the lows and kind of give you the range. It kind of just, you get a visualization of where most people, where their heart rates fall. See, when you look at this, you can't really make rhyme or reason when it's listed this way, like randomly. But when you do it this way, you can kind of get an idea of where most people's heart rates are. So Mia noticed that there were many different heart rates. She decided to make a dot plot to show the different heart rates. She drew a number line and started numbering from 78 to 92. Now you'll notice nobody had one at 78. So when you make these, start with a value that's slightly lower than the lowest heart rate or data point or whatever it is that you're collecting, and make sure that it includes the last data point. And you can even go, if you wanted to 92 if you wanted to. Just to kind of, you could do that if you wanted to. She drew a number, and she actually did, but it didn't print out because it says she numbered from 78 to 92, but it didn't show up when they copied and pasted this into the smartboard. Then she placed a dot above the number on the number line for each heart rate. If there was already a dot above a number, she added another dot above the one already there, and then she continued until she had one dot for each heart rate. So how many dots total should there be, not including hers? There should be 22. So kind of just keep that in mind when you do this. What I would do is after you do all of your data points, count them to make sure you didn't leave any of them out. Okay? Just a little checkpoint. So now let's take a look and analyze the data. Raise your hand. What was the heart rate for the student with the lowest heart rate? Ava, 79. What about the highest? How many students had a heart rate greater than 86? But raise your hand now, okay? Serenity? Does everybody see that? Why it's 5? Greater than 86, which would be this. Greater than 86. Remember we did that last module? Not greater than or equal to, it's just greater. So that's 5. What about, raise your hand for this. What fraction of the students had a heart rate less than 82? Fraction. Greg? It's 2 out of, do you see why it's 2 out of 22? Okay, ready? Less than 82. So that would be this, right? There's 2. There's a total of 22. So you could say 222 or 1/11th if you reduce it. So both of them are acceptable. because I have two that are less than 82. This is an 81 and this is a 79 out of a total of 22 students. So they didn't ask for a fraction. Yes, they asked for a fraction here. So and then 2 out of 22 can be reduced to 111. That's why we reduced it. What's the most common heart rate? Most common. Raise your hand. Lauren. Does everybody agree with 83? Why? It has four people that had that rating. Nobody else had that many. So it is 83. What heart rate? This is a really important question. Put a star next to it because we're going to continue to develop this idea of what's called the center of the data. What heart rate describes the center of the data? And when you think of centers, where do most people fall? Kind of, and it doesn't have to be an exact number. You can do a range. The center of the data. Taylor, what do you think? 84, but if you kind of look, you don't want to leave out this here. Give me a range of where most of those dots fall. 83 to about where? I would agree. 83 to 86 is kind of the center. That is a question that you will see over and over again in the next few lessons. Because most of the dots are in this area right here. Okay? It doesn't necessarily mean it's going to be the center of the actual line graph because some of the values could fall towards the left or towards the right. It's where they kind of cluster together the most. Okay, visually where they cluster together the most. What heart rates are the most unusual heart rates? So now you got to look where it thins out. Where does it thin out? Michael. Yeah, so what's the lowest and what's the highest? 70. Well, there's nobody that has 78. Okay, so if 79 is unusual because there's nobody else there, you can make an argument for 81 because only one person had that. You can make an argument for 87, the 89 and 90, sure. Uncommon means unusual. If Mia's teacher asked what typical heart rate is for sixth graders in the class, what would you tell Mia's teacher? Sam. If you wanted to, you can expand it to include a range. So if you do it, yeah, a center of the data and most typical can mean the same thing. So anywhere between 83 and 86 is acceptable. And now you get to make your own dot plot. Nope, not yet. It's coming. Okay. 10. How does Mia's heart rate compare with the heart rates of other students? Yeah, I said add the point for Mia's heart rate. So we'll go back. What did she have? 80? Okay, add her dot. I did it in a different color so you could see it. If you want to put an X for it instead, you can so you can see it. Now you got to compare it. How does Mia's heart rate compare with the heart rates of the other students in the class? Is it typical? No. Is it on the high end? Is it on the low end? It's on the low end because only maybe one or two other people have low heart rates in that range. So it's almost the lowest, but not quite exactly the lowest, right? Almost the lowest. All right. Yeah. If everybody fell in this range between 79 and 81, and there was one way out here where I have to at least count up to that, but all the dots are clustered towards the beginning, the center of the data would be on the low range. Oh, it's a good question. We're going to show you examples of what to do with that. Okay. What she's saying is, what if you had a bunch of dots here, 4, and then there was like nothing but ones and zeros here, and then you had another 4 over here. What would you do? We'll show you what to do with that. Okay. And those are the examples where sometimes dot plots are not the best visual um, representation of what to do. Then we got to look at towards what's called getting means, modes, and medians, which is also coming up later. Where? Yeah, where? This is where we are right now. Is this where you need me to go? Okay. Example 2. Mia's class collected data to answer several other questions about her class. After they collected data, they drew dot plots of their findings. Here's a dot plot showing the data collected to answer the question, how many textbooks are in the desks of 6th graders? All right, so what's the range? 5 to 8. When the students thought about this question, many said that they all had about the same number of books in their desks since they all take the same subject in school. The class noticed that the graph was not very spread out, which is also considered low variability, since there are only 4 different answers that students gave, 5, 6, 7, or 8, with most of the students answering that they had 6 books in their desk. Okay? Okay. Another student wanted to ask the question, how tall are the 6th graders in our class? When students thought about this question, they thought that the heights would be spread out, high variability. Since there were some shorter students and some very tall students in class, here's a dot plot of the students' heights. So this time it ranges with what on the low end? Not 45 because there's nothing there. 49 to 66. So that's a lot more spread out, which we call wider or greater variability. Okay? On the next page are 4 statistical questions and 4 different dot plots of the data collected to answer these questions. Match each statistical question with the appropriate dot plot and explain your choices. Let's take a look. What are the ages of 4th graders in our school? Okay, so now I got to think about 4th graders. How old would they be? In that range, 9 to 10. So is this a possibility? It is. Dot plot B. It goes from 0 to 8. That's not going to match up, is it? Dot plot C. 1, 2, and 3. Is that a possibility? No. And 58 through 73. She was joking. She was joking. So obviously, dot plot A matches up with this statistical question. Do 12 through 14 together. What are the heights of the players on the 8th grade boys basketball team? So it's in inches. So I don't know, unless they got a little miniature leprechaun playing, I'm going to say it's probably not going to be B or C. So dot plot D, right? In inches, that's about, within that 4 to 5 foot range. So I'm going D here. How many hours do 6th graders in our class watch TV on a school night? Probably C, right? You could maybe make an argument for B, but I would go C. TV on a school night. I'm thinking 1 to 3 hours, guys. I'm not thinking 8 hours. There's not even 8 hours after you come home from school for you to watch TV. Does everybody agree that C is the better choice? And then languages. How many languages do students in our class speak? C also. You could go with none either too, because I don't know. 14? It's just the thing that makes it difficult is you got some here that are speaking 4, 5, and 6 different languages. That's weird. All right, so it's arguable. Everybody speaks one language, their own. 14, C. All right, go with C. All right.